Alright, here is a practice problem for chapters 3 and 4. So I'm looking at the problem from page 130, and this is number 65. Okay, so this problem says a 1,380 kilogram car is moving due east with an initial speed of 27 meters per second. After 8 seconds, the car is slowed down to 17 meters per second. Find the magnitude and direction of the net force that produces the deceleration. So this problem is nice because it includes kinematics and it includes forces. So let's start by writing the given information. What do we know so far? We know that the mass is 1,380 kilograms. We also know that the initial velocity was 27.0 meters per second east. We're given the time is 8.00 seconds. The final velocity, it says it slows down to 17 meters per second, so we're assuming that's still east because it didn't say that it changed directions. And that's all the information that we have. So we're asked to find the net force, F net, equals what? Alright, so how do we link force with all this stuff? Well, we know that the net force equals mass times acceleration, and we know acceleration can be linked with all this stuff, the change in velocity over time. So we know the mass, check, but we don't know the acceleration. We have to find that out. So using this stuff, do we have a kinematics equation that has A and these things in it with nothing else? We do. It's this one. Equals V naught plus A times T. So if we rearrange that for A is going to be V minus V naught divided by T. So if we want, we can plug this expression in over here for A. So then this becomes F net equals M times V minus V naught divided by T. You could have just solved for a number for A here, but it's good practice to plug it in and get an expression for the answer first, because sometimes you have things that cancel out, and sometimes you're going to be asked to do that. So now we can plug in all of our numbers. We have 1,380 kilograms times 27, V was 17, not 27. So we have 17 meters per second. I'm ignoring sig figs here for the sake of fitting it all on the page. And then divided by our time. So if you calculate that all out, you can pause if you want to do that first on your own, but F net should equal negative 1,725 newtons. So the question asked, find the magnitude and direction of the net force. So since the direction was given as east in the problem, we should put our direction in terms of north, south, east, or west. So this negative here, what does this mean? Well, since we said east was positive, we didn't explicitly say east was positive, but we assigned this eastward velocity as a positive value. So that means a negative value that we get would be west. So this really means west. So to summarize, our answer, F net equals 1,725 newtons west. And that's our answer. If we wanted to round off for sig figs, that would be 1,730 newtons west. So that's a little bit better answer. Okay, and that's it.